Hi everybody, so today we're going to do a little bit of a preview talking about angles because we're going to move forward with our talk on geometry. So we just need to go over a few vocabulary terms that you should be familiar with, and if they aren't coming back to you, that's okay, we're going to do a little explanation. So we have to talk about a few different kinds of angles, and these are going to sound familiar to you. So the first type of angle we're going to talk about is a complementary angle. So a complementary angles, those are angles that when you combine them, they measure to be 90 degrees. So let's see an example of these complementary angles. So let's say we have an angle here with a measure of 15 degrees. Not perfect, but close enough. So 15 degrees, so an angle that would be complementary to this would make the sum be 90 degrees. So the angle that's complementary to 15 degrees is 75 degrees. So you can have angles that are not beside each other be complementary. So these aren't touching, they're not adjacent, but they are 90 degrees. A lot of times you're going to see complementary angles represented like this. So we know that these are complementary. They'll use this little symbol. They will make a little box right in this corner, and that box is going to tell us that this whole angle, A and B together, is 90 degrees. So that's a complementary angle. The next type of angle that we're going to remember about is our supplementary angle. So supplementary angles are angles whose measures add up to 180 degrees. So when you combine these angles, these supplementary angles, they add up to 180 degrees. So let's take a look at an example of supplementary angles. So here's one way that we can represent supplementary angles. We can just put them as angles that aren't adjacent, they're not touching each other. But you can see that 30, 60, and 90, they're going to add up to 180 degrees. But more often, you're going to see supplementary angles represented like this. So here we can see that these make a straight line, these three angles added together, A, B, and C. And when they want to show you that angles are going to add up to 180 degrees, that straight line, what they do is they add this round mark. So that semicircle inside angles, that's going to show you that this whole thing is going to add to 180 degrees because that's a perfectly straight line. The last type of angles we're going to talk about, these are vertical angles. So vertical angles are two angles that are opposite one another in an intersection, and they're congruent. So let's unpack this definition. So the first part that's really important is congruence. So congruent is just a way of talking about angles. That means that they're the same. They're the same measure. So if I have two 90-degree angles, they're congruent with each other. They're the same size. If I have two 30-degree angles, they're congruent. They're the same size. So vertical angles are two angles that are congruent. They're the same size, and they're found on opposite sides of an intersection. That's where two line segments or lines are going to cross and meet. So let's take an example of this. So here we have two lines intersecting, so they're crossing one another, and this is going to create four different angles like you see here. So our vertical angles, they are angles that are on opposite sides and they're congruent. So what we see here is we see actually two pairs of vertical angles, and I'm going to label these so that they're a little easier to talk about. So we have angles 1, 2, 3, and 4 in this intersection. So what we're going to see here is we're going to highlight a pair of vertical angles. So from our definition, we know vertical angles are two opposite angles from this formation of an intersection, and they're congruent, they're the same size. You can actually see here that our opposite angles, they're right across from each other, 1 and 3 and 2 and 4. You can see visually that they are the same size. 1 and 3 are the same size, and 2 and 4 are the same size. So we have one pair of vertical angles here, angles 1 and 3, and we have another pair of vertical angles here, angles 2 and 4. So let's take a look at these types of angles in a diagram all together. All right, so here let's label some things. We have our diagram, we've got a bunch of different lines here. We can see that we have a 90-degree angle here, a 180-degree angle there. We've got some other things crossing. So let's look for a pair of complementary angles. So I'm sure you can identify a pair of angles here, two pairs of angles here that are going to add up to 90 degrees. So these two angles I just starred, those add up to 90 degrees. And remember that they do because this square is telling us that this whole angle here, that's made of these two smaller angles, is 90 degrees. So here we have our complementary angles. Next, we're going to look for some supplementary angles. These are angles that add up to 180 degrees. So we know that we're looking for a straight line. We've got a few examples of a straight line here. We have this guy, that all of these add up to 180 degrees, but we also have this straight line. So I'm going to use this one down here, and we can see that these two angles are what make up this 180 degree line. They make up the line. So these two angles here are supplementary. Finally, we have our vertical angles. So these vertical angles, they're on opposite sides of an intersection, and they're the same size. They're congruent. So we have a lot of different examples of some vertical angles here. Let's take a look at one. This angle here is vertical to this angle. And you can tell this because they share lines. And I know that this can look a little confusing, so we're going to be a little bit clearer here. You know that they're vertical because they are made of the same lines crossing. This is the bottom of this angle, and this is the side of that angle. You can see those two lines are the exact lines that make up this one here. So it's really important to recognize that just because angles look diagonal, it doesn't mean necessarily that they're vertical. You have to double check that they share those same two lines that make them up. So here you have it. You have your complementary angles that add up to 90, your supplementary angles that add up to 180, and your vertical angles that are diagonal from one another, and they are the same size. They're congruent. So now that we've learned and remembered about those complementary, supplementary, and vertical angles, we're actually going to use that information to solve the size of different angles. So I have in my diagram here a bunch of different lines that have come together. So 3 different lines, line AD, BE, and CF, that have come together to form a bunch of different angles. We have 1, 2, 3, 4, 5, 6 angles. The really cool thing here is using the information of complementary angles, supplementary angles, and vertical angles. Even though we only have one measurement here, we can figure out all of the rest of these. So we're going to start by looking for vertical angles. So we're looking for an angle, a vertical angle, that is going to tell us a measurement. So remember, our vertical angles, they are angles that share two lines that intersect, and they are diagonal from one another, and they're the same size. They're congruent. So we're looking for the angle that is vertical to angle EOD. So we know EOD is 32 degrees. So we're looking for something that shares those same lines that make up this. So which angle would that be? All right, so using vertical angles, we now know the measure of angle AOB is also 32 degrees. All right, so I labeled that in blue as 32 degrees, and I wrote also in blue vertical, as in we solved the measure of this angle using vertical angles. So next we are going to see what other angles we can identify. Well, we already know that this little square means that an angle is 90 degrees, so it gave us this already. Now let's see, can we use any more vertical angles to find the measure of any of these other remaining unknown angles? And we can. We know that angle AOF is comprised of the lines AD and FC. And that's true for another one of these angles. We know that angle COD is vertical with angle AOF. So we can use vertical angles to find that this is also 90 degrees. So the last thing we are going to do is we're going to use some of these other kinds of angles to figure out what angle FOE is and what angle BOC is. And I'm sure you can realize here that these are vertical angles. So they're going to be the same size. And there are two ways we can get this. So we're going to go through both ways. First, we're going to get the idea of supplementary angles. Remember, supplementary angles are angles that add all up together to equal 180 degrees. So we can see here that angle FOA, AOB, and BOC all are going to add up to 180 degrees because they form that line FOC. So what we can do is we can use those supplementary angles to remember what this is. So we know that 180 is going to equal 90 plus 32 plus whatever this is. So 180 equals 90 plus 32 plus unknown. We'll just put an x. So we're going to use some algebra to solve this. You know, that 180 degrees, this whole line is going to equal these two, 122 degrees plus x. So x has to be, so that's right, x has to be 58 degrees. So we now know that this angle is 58 degrees. And we know that because of supplementary angles. And I'm sure you're thinking, well, now we know what FOE is. We can use vertical angles here, and we can. But I want to show you how we could use complementary angles here as well. So we could also reason here that, well, we know 90 and 90 equals 180. So these two angles here must equal 90 degrees. So what we can do is we can set these two added together equal to 90 degrees. So 90 degrees, these complementary angles together, 32 and whatever this is, x, are going to equal 90 degrees. So we can use some algebra here to figure out what x equals. And we know that x is going to equal 58 degrees. So these are how we can use vertical, supplementary, and complementary angles to solve for an unknown.